Hello, statistics student. This video is for chapter 4.3, Binomial Distribution Part 3. We were working on the work problems of finding probability of a number of customers that will buy a book, and this store manager knows that the chance of one customer that would buy a book is 0.095, and there is 24 customers that comes in. So we're looking at what is the probability of at most 2 customer will buy a book out of the 24. So when we say at most 2 customer, it is always out of 24. It's a fixed number. So because we're looking at most 2, so that would be means 2 or less, right? 2 or fewer. So this means at most 2 is 2 or fewer. That means 2 is the largest number. So that means 2, 1, 0. So, or you can do 2 or fewer. So you would use 2 at most 2. So you use 2 or fewer. And you just plug in 2 and then you use the X or fewer, you would get it. So let's use the calculator. It is analysis, probability distribution, binomial distribution. It would show this. You enter n is 24, p is 0.095, and we know 1, 2. At most is 2, so it will be 2 or fewer, 0.5977. 0.5977. Okay. So E is the number of non-significant range of customers who will buy a book out of 24. So if 24 customer comes in, what is the normal things that will happen? So if 0.09% will buy a book, so we will use the parameter to calculate. So one thing we can do is, well, we are actually have already done these 24 and 0.095 to find x. The mean and standard deviation is already here, so we can just copy this. 2.28 and 1.44, right? 2.3. So 2.28 is 2.3, SD is 1.44. The non-significant range will be from the mean minus 2 standard deviation and add 2 standard deviation. So that means from 0, negative 0.58, that means 0 is not surprising. Then up to only 5.1. So 5 customers that buy is not surprising. It can happen by chance, but more than 5 is almost unlikely to happen. So this is very useful for you to gauge what is, something that is very usual. The last example I want to do is has to do with an application. So kind of like if you know that a particular booked passengers book a flights, but due to various reasons they might not show up. So and in this particular airline, they find that 78% chance that a booked passenger will actually arrive. So there's 22% that a passenger won't arrive for a flight. So this small airline, because sometimes people don't come, they don't want to waste the seat, they would book more than is required for a flights. So this airplane can only seat 53 passengers, but because some of them might not come, for every one of them, there's 78% chance that they don't come. So they book more. They book 60 people on an airplane. As many of 60 persons? I think passengers, maybe. Okay, so we want to find the probability that if the airline books 60 persons or 60 passengers, what is the chance that there is not enough seat? What happens if there is not enough seat? Because you only have 53 seats, it must be 54 or more arrive, right? Up to 60. 54 or all 60 arrive. There's a chance that 60 would arrive. So what is the chance of 50 or more? 54 or more arrive. Not enough seat. If only 53 or less arrive, that is okay, right? But if it is 54 or more, we have a problem. We have to ask people to, to go. So this is the 54 or more cases. So we would say the the number of customers is 60, and then the chance of arrive is 0.78, and we want 54. We want 54 to come or more, not just 54, but more. So in this case, it's 0.0013, right? We use 54 and we use X or greater because actually that is 0.013. So it's very low chance of this happening. So it's actually quite good. Find the non-significant range of passengers who would arrive out of 60. So what is the range of having 60 passenger, but what is the range of customer that would arrive? So we will calculate mean, which is n times p, and it is already over here instead this 46.8. The standard deviation is 3.21. So the non-significant range is 46.8 minus 2 times standard deviation to the mean plus 2 times standard deviation. So that is 40 to 53. That means if you book 60, the chance how many customer will come, it can be as low as 40 and as high as 53.2. So 53 is still normal. So it's still quite possible that you would have a full flight. But it could be so it is not, it is quite unlikely to have the case where it is not, you don't have enough seats. So this planning is pretty good. Although you might feel that wow, you booked too much, but it's really because of this number. 53 is quite normal. So you would not be surprised that 53 would exactly come, and you would not have case. It's very rare, so it's unlikely to happen that you have 54, you have 56, or you have below 40 customers arrive. So this planning is good. So you can use binomial distribution, the parameter, to figure out when is a particular policy works or not. So this is an application that is useful for binomial. And the same application can be used to plan, like in an airplane. You know that certain percentage of people like vegetarian food, or certain percentage of people like to choose beef versus chicken. So you can, just plan ahead on how many vegetarian food you can prepare. You don't want to prepare too much. You don't want to prepare too little. So you can do the range things, or you can say, okay, if I have only that much, what is the chance that I will run out? Okay, so a lot of application in the real life.